consider an illustration. When we say something is difficult to learn, what do we mean? Well, part of the answer is shown in this demonstration of an easy memory task. See how easy it is for you to learn this sequence of information. A, 1 January, B, 2 February, C, 3 March, D, 4 April, E, 5 May. The easy memory task contains 3 series that you already have in your long-term memory. Digits, letters, months of the year arranged in a simple cycle. The demonstration is simple but makes an important point. How easy it is for you to learn new material depends on whether you can relate it to things you already know, whether you can find familiar patterns in it. Just as you have been trained to read English words immediately as chunks, so can an experienced chess player quickly recognize significant attack patterns of chessmen arranged in board positions. So can an organic chemist quickly recognize familiar molecular structures, or a musician recognize simple musical themes in a composition. So can the informed football fan recognize complex patterns of team movements as a football play is run off during a game. The expert exceeds the novice in the sheer number and complexity of patterns he can identify from memory. Consequently, for the expert, any new chessboard configuration or new musical composition is analyzed into just a few familiar patterns. On the other hand, the novices among us must deal with a composition at the level of single symbols or small patterns, where the amount of new information simply overloads our ability to assimilate it in one shot. But even for the expert, new information can be difficult to learn if it isn't organized into familiar patterns. Suppose you had to learn the following series, one of letters, one of digits. These series appear nonsensical, but that's because familiar patterns are hidden by groupings which mislead you. If we rearrange the groups, the new organization becomes significant because it now matches familiar patterns in your memory. Thus, the numbers are seen to be the 7 series, whereas the letters become 4 well-known initials rather than just 12 unrelated letters. And of course, it's easier to remember 4 things than 12 things. The important idea here is that your brain tries to recognize large chunks of familiar patterns in the material you're trying to learn. Each chunk is then entered as a unit in your short-term memory. You might think of your short-term memory as a workbench or countertop onto which you place a box corresponding to each chunk as you attend to it. There's only a limited amount of space on the counter, so that eventually adding a new chunk or box to the counter causes some other one to fall off. The countertop that is our short-term memory seems to hold about 7 chunks before it becomes overloaded. An interesting fact is that the space that a chunk takes up in short-term memory is relatively constant and doesn't much depend on how large is the pattern of material the chunk refers to. For example, consider the following sequence of items. If we simply count symbols, there are about 48 there. A letter, a digit, a 1-syllable word, an abbreviation, a 2-syllable word, a 3-word phrase, a familiar proverb. These form 7 familiar units, each one of which will take up about 1 space on the workbench of your short-term memory. Since information, if unattended, is rapidly lost from your short-term memory, it is of crucial importance for good memory that you concentrate upon learning new material while it is available in your short-term memory. We speak of learning as this transfer of information from short-term to long-term memory. Now, people have acquired several methods or memorizing strategies to speed up this transfer of information into long-term memory.